Hi folks, this is Bill from AT Makers, and just a quick update on our work working on the SCATIR switches. These are blink switches or other proximity switches that came out a few years ago, a dozen years ago. Were sold by Ablenet and now discontinued. We've gotten a couple of requests to either replace them or repair them. We got one in last week, 2 weeks ago, and thanks to John Jordan and some work I did, we were able to figure out what was wrong with it and fix it. In this video, I'll walk you through what we found and how we fixed it, and then I'll get it sent back. So just as a quick reminder, this is how the SCATIR switch looks and works here. You'll see as I blink my eye, you can see that relay going on and off. And you'll see that we're actually using this little key switch, one of our boxes here, so we can test it out pretty easily, make sure that it's working correctly. In fact, if you look over here, you'll see that every time I blink my eye, I'm getting A's, which is what I'm supposed to get. If I hold it down, I'll get it for a while. So, obviously we put in debouncing there to make it useful, but it definitely is showing that the switch itself is working correctly, which is a big improvement compared to what it looked like when we got it. Now, if you watched the long video with John Jordan and I the other night, what we found was that when we got the device, when it was on, it would be sensing the sensor would be getting power and be working. And when I blinked, we would hear the tone. We would see the relay on happen. This light would go off. But whatever was plugged into the relay outlet wasn't being activated. And it made us think that either this jack had gone bad, which is fairly likely because when you're moving something in and out, it can get dislodged, or the relay inside the device was likely to have failed. So here's a look at the board. This is actually after we've done the repair. But there are actually two relays here that could be causing the problem. There's this little one down here at the bottom. It says Omron. And then there's this blue thing up here. And it didn't look like this when we put it in. I'll show you the old one. It kind of looked like a coil, like an inductor, which it kind of is. And this ends up being the part that we needed to replace. The other things that could have gone wrong would be this jack right here, or perhaps one of these small components in this output signal. A lot of times what you're going to find when you're trying to repair something like this is you need to look for things that are that either move or that get hot. So you're going to look at things like relays, jacks where you're moving the pieces in and out of them, and then look on the board when you open it up for anything that looks like it got hot or might have burned. When we looked at, we didn't see any of that. Basically, we found these two relays, and this relay over here, once we realized what it was by far the most likely thing to have failed. Now here are the two relays, the old one that we took out of the board here, and the new one we replaced it with right here. And you'll see if I turn these around, they actually have exactly the same pins and exactly the same positions. Really the difference is that the one on the left, the original one, just doesn't have this dust cover on it. It was kind of hard to find this part. It's discontinued and not easy to find. We actually found it. Somebody online was selling these old Radio Shack versions of them that were good fits. And I got to thank the folks in the Adafruit community. I reached out to Adafruit, and some folks in their community on Twitter actually helped me find some of these. So I ordered them online. Actually ordered them from, turn these around. Ordered them online from Amazon and got them in a couple days. They were about $5 a piece. I've ordered 4 of them just in case I screwed up. And then my next step here was to figure out a good way to test the new one, which I assume works, and then perform the same test on the old one, make sure that it was dead, and if it was dead, go ahead and swap them out. All right, so in order to determine if the relay was the problem, I got a replacement relay, and first I'd like to see what the characteristics are here, what it turns on and off at. So this is the relay. It does have a dust jacket, otherwise it's the same basic part. I have the coil leads on red and black here hooked up to my power supply, which is currently at 0. And then the normally open and common pins, so the switch pins, are connected to my multimeter in continuity indicator mode. So all I'm going to do here is I'm going to turn up the voltage slowly and wait for this to activate. So I can't really get them both in screen here, but I'll turn this up and you'll hear the noise when it kicks in. All right, so right at 2 volts, this starts conducting, and then I'll bring it back down. I'm sure it's going to be significantly lower to cut off. All right, so about somewhere around 1.1, 1.2. So that makes sense. The voltage, the coil voltage needs to be about 2 volts to activate the relay, and then once it's going, it has to go down to about 1 volt or 1.1 volts before it will kick off. So my next step here is to take the existing relay out of the scatter switch and run the same test. All right, so now I have the old relay that we took out wired up the same way, and I'll turn up this voltage above 2, even up above 3, and I've got no continuity. So this relay is not working. I am worried that I'm not getting a good connection on the breadboard, so I'm gonna wire it up with alligator clips first, just to double check. And just to make sure that I was getting good contact to the breadboard, I went ahead and wired these up separately to the breadboard. I have no continuity, and I'm all up almost to 4 volts. So there's plenty of voltage across the coil, and it is not conducting. So this relay has died. All right, here's the new relay in place. It went in pretty easily once I got the old solder holes cleared out. I also replaced this this ground connector from the battery was failing. This one looks better, but the negative was definitely failing. So I went ahead and put a new one in there, and now it's just a matter of powering it up and see if it works. All right, so I have the sensor plugged in. It's on my face, and you see that it is calibrating and sending the pulses out. And you can actually hear if you listen real carefully, you can hear a little chirp after the tone. You'll hear the relay go, and you can tell because every time I blink, the switch fires. The switch fires on and closes the relay. So it's totally working. So I'm going to wrap this thing back up, and then I'll probably send it back where it came from. So I'm really happy that this is fixed and ready to go back to its owner. Sue O'Neill sent it to me for Casey. I hope this works. I'm pretty sure it will work just the way it used to. I'm also going to send this key switch with it. It's inexpensive. I've got lots of them around here. If you want to let me know, I can either send you one that's programmed to send keystrokes to a computer, or I can program you one that's programmed to be an input to the Xbox Adaptive Controller. It's the same hardware, it's just a matter of which software I load on it. So I'll be happy to send that out and get that back to you. We learned a couple things on this that were surprising. By the way, I noticed that in my demonstration, sometimes you wouldn't see the continuity tester light up just because it didn't hold on long enough. So if you watch here, that's why we put it on the tester, so that every time I wink, it activates, and you can see it on there. I'm actually really impressed with this device, right? So it really does a good job of being adaptive and recognizing false positives and false negatives. It really is a very well-tuned device, and you got to hand it to the people at Michigan State University who developed this thing 10, 15 years ago. I'm going to reach out to them. One of the problems with this device, let me turn it off so it stops beeping at me. One of the problems with this device is that it is patented. So the self-calibration part, the way that they calibrate this device to detect blinks and not detect false positives is patented. And there are pros and cons to that. The pro is that once we realized that, John and I were able to download the patents, and the patents lay out exactly how this thing works. And it's no longer a mystery of how this thing works. It's defined there. And when that patent expires, everybody will be able to use this technology, and it will be useful in things other than blink switches. Until this patent expires, it will be hard for us to make an open source replacement unless we get MSU to give us a license to make one for free. It's possible. Open patents exist. In the AT space, patents are really problematic. I have a problem with them because they really do limit people from achieving their potential. That's kind of what patents do, is limit the number of people who can do this. And when this is assistive technology, I have a small problem with that. My problem at the moment is the fact that something like this $5 switch is going to make somebody completely unable to communicate. Because the problem is that Ablenet, one of the problems is you can justify defending a patent when the product is available in the marketplace. But at this point, Ablenet has stopped selling this product, and there is no replacement on the market for it. And with the patent in place, it's awfully hard for people to replicate it without going to the person who owns the license. Now, if that is MSU, if that's Michigan State, that's totally doable. We can make it. Somebody else can put it on the market. I don't have a problem with that. If that went to Tash, which went to Ablenet, and they're now the people who are controlling that patent, that makes it very hard for blink switches to exist. So we've got a little bit of research to do here to see what our best step is. If anybody knows people at the Artificial Language Lab at Michigan State, my email is bill@atmakers.org. Have them give me a ring. I'm going to reach out to the folks who are on the original patent and see if they'd like to work with us. That's about my update on this. I'm not a huge fan of the fact that I could follow the instructions for the self-calibration and make one open source. It would be a fraction of the size, a tiny fraction of the cost. But there are things we can't do, and we certainly can't just ignore a patent that's still in place by a company and a school that are still very much still around. So if you have questions, let me know. I will get this thing back out in the mail. We certainly know enough now that if one of these dies, we probably know how to fix it. It's not a complicated device. With the patent in place, we know exactly how it works. So I will be happy to fix any of these that you have that are broken. If I get a flood of them, I will train other people to fix these when they are broken. So at the very least, we can keep people being able to communicate. It's not what I would like to do with this. I would like to make one, the size of, the size of the key switch, right? Make one. Sorry, great video. I'd like to make one about this size right here that has no power cord and just directly sends keystrokes or joystick controls. There's no reason we can't do that. We could even pair it with a pressure sensor, so you could have a blink switch or a suction switch or whatever. There's all kinds of craziness we could add to do this. I'd love to. But at the moment, I'm going to focus on repairing the ones that we find in the wild that are dead and working on getting that patent liberated or licensed. They can give us a license to do it for open source without granting it to anybody else. That would be fine too. We don't have a ton of money. We're not going to give them a ton of money, but I'm open to suggestions here. So I hope that you're all doing well and you're staying safe. Get your flu shot. I got mine on Monday. Yes, you still need a flu shot, even though everybody's social distancing. We certainly don't need to add anything on top of COVID this fall. I will update later in the week, and I'll have a great week this week. As always, good luck and have fun.